So now let's take a look at division of radicals. So first off, we have something called the quotient property of radicals that tells us that if you take the square root of two numbers, it's the same thing as splitting it up. So if you have the square root of x over y, that's the same thing as the square root of x over the square root of y. All right, so you can see with numbers as well, right? And if we had mixed radicals, then it's going to be the same, but we can just multiply our coefficients, like m over n, in the end, and we divide our coefficients m over n, and we divide our radicands as well. So just like before, the steps are great to look at, but let's just try a few, and I think start to get a feel for this. So this one says simplify the following radical expressions. So all we're really going to do here is just divide our coefficients, so 12 and 6, and then divide our radicands. So 12 divided by 6 is 2. 6 divided by 2 is 3, but it's got to stay under the radical. So there you go. That's it. Okay, looking at B. So we have 6 over 4, so we'll simplify that. That's all we can do there because we don't really want to get a decimal in this case. So if we were to simplify that fraction, I see they're both even numbers, so I can divide 6 by 2 and 4 by 2. So this becomes like 3 over 2. I'm just leaving a line here because I'm going to simplify these guys down in a second too. Now in these ones, I can simplify those fractions too. 40 ends in a 0 and 45 ends in a 5, so 5 goes into both of those. So let's divide those. Let's say this is the same thing as the square root of 8 over the square root of 9. Well, that made things actually quite nice because the square root of 9 popped into the question. And that's a perfect square, right? So instead of writing out square root of 9, that's just 3. So let's just call that 3. So I'm going to write it one more time here. So 3 root 8 over 2, and then instead of root 9, I'm just going to say times 3. Okay, so this is 3 root 8 over 6. Now, looking pretty good here. We can simplify this now. Actually, and we could. You can do these in different order. I was going to say with the 8, we can also take something out of there, right? Because I can write that as 4 times 2, and I can simplify a bit more. Let's simplify this first. It's kind of just nice to deal with smaller numbers. So this is like 3 over 6. That's the same as a half, right? You divide the top and bottom by 3. So now what we have left, let's start up here, is the square root of 8 over 2. And if you're wondering where I got that, that's like 1 over 2, right? It's like 3 over 6, 1 over 2. And now I'm just going to simplify the 8 there. So this can be rewritten as 4 times 2 over 2. This 4 gets to come out as a 2, because that's the square root of 4. So now I have 2 root 2 over 2. And now I can see that these 2's would also cancel. So that 2 cancels with that 2. And we end up with just the square root of 2. Okay, so for C, this one's going to be a bit easier. So I can see that 36 is an even number, 2 is obviously an even number. I can just go 36 divided by 2 right out of the gates. So this is square root 18. And if we were sticking to our rule there, you can think of this as being like over the square root of 1. But the square root of 1 is just 1, so it's like a cancel. I don't really need it there at all. So now I just have the square root of 18. And then we'll just simplify that, because 9 can go into that, right? So the square root of 9 times 2. And then the 9 gets to come out as a 3. So 3 root 2. For D, I see that my coefficients can go into each other. So 20 divided by 4 is 5. And here I'm going to draw my line, just kind of keep it in the same place. 40 divided by 5 is 8. So I've still got root 8. And it was canceled again, right? Like everything in the bottom canceled out there. So I don't actually even need that line. Everything's in the numerator now. And again, 8 I can write that as 4 times 2. That 4 gets to come out as a 2, and it's going to be multiplied by the 5 that's already out there. So 10 root 2. Now, what happens if it doesn't go nicely into it? Like, for example, in these ones, right? 2 was a factor of 6, so you could go 6 divided by 2, and it worked out pretty much every time, so it worked out nice. What happens if that doesn't work? Well, you can't divide them because we're going to be stuck with the number in the bottom at the end, like in the denominator. But what we don't like having is we actually don't like having, like in this first example, 7 over root 7. We don't like having a square root in a denominator. And the reason for it is because this is an irrational number. We're dividing by a number that is like pi. So if you remember, pi is a number like 3.14, and then there's all those digits that like never repeat type of number, right? So that's an irrational number. And in math, we don't like dividing by those. So we rationalize the denominator. So the better way to leave your answer is to not have a square root in the bottom. It's fine to have it in the top, but not in the bottom. Okay, so here's going to be the strategy for doing that. So this square root right here, what we're going to do is we're going to multiply by, and just bear with me for a second, it's going to be root 7 over root 7. All right, so first off, root 7 over root 7, what would that be equal to? Something divided by itself. Well, that's just 1, right? We didn't actually change anything, because if you multiply by 1, it's exactly the same number as it was to begin with. It's just written in a different form. Okay, so we didn't change anything. But why root 7? Well, the reason why we chose root 7 here is because I want to get rid of this square root in the denominator. Do you remember from above, when you multiply the square root of 7 times the square root of 7, the answer there is just straight up 7. Because if you had the square root of 7 times the square root of 7, that's like square root of 7 squared, which is just, like those cancel, and it's just 7. So that's how we're going to rationalize the denominator. So get rid of the rational number in the denominator, or get rid of the irrational number in the denominator. Okay, so multiply the bottoms there, so that's going to be just 7, right? Root 7 times root 7. But then we still have to multiply the top. So you've got 7 times root 7. Well, that's just 7 root 7. Okay, and now I actually have 2 coefficients of 7. Those can cancel. So my answer here is just root 7. Okay, now we can do the same thing on this one as well, but you just always want to check that it's not possible just to divide them. So in this case, 5 goes into 15, so I'm not going to multiply, the bottom and the top by root 5. It would actually work, but it's just more work than it needs to be. Let's go 15 divided by 5 is root 3. Right, that was easy. Okay, so if you can, make sure you're looking for that. Okay, so now in this one, we can go ahead, like if you wanted to, again, there's different ways to get here. We could multiply the bottom and the top by root 6. That would totally work. Everything would work out fine. But you can also simplify to begin with if you want. So you've got root 2 over root 6. That would be the same thing as having like root 1 over 3 root 3, right? And root 1, you wouldn't leave it as root 1. That's just 1. So this is the same thing as like 1 over 3 root 3. Okay? I just did that just so my numbers are smaller. Just 3 is a little nicer to work with than 6. You wouldn't even really have to do that. And it also is going to stop me from having to cancel more when I'm done too. Like it's not like this is more work. I kind of did that step now instead of simplifying things later. So there's many ways to get to these. All right. So now I need to rationalize this. So I'm just going to multiply by root 3. All right, root 3 over root 3. Common place to make a mistake here is students would multiply top and bottom by 3 root 3. And actually, that wouldn't even really be a mistake. Like it'll still work. you'll just have more to simplify again in the end. But all I really need to do is multiply by root 3 over root 3. So I'm just going to keep it to that. Okay, so now 1 times root 3 is just root 3. Now in the bottom here, I've got 3 times, and then root 3 times root 3 is just, so there's that 3. Root 3 times root 3 is just straight up 3. So now what I have is root 3 over 3 times 3 is 9. So my answer is now rationalized because I don't have the square root in the denominator. Okay, let's take a look at D. So again, they are trying to trick us because we can divide those. So I could have went root 50 over root 50. That would have worked, but it would have got pretty messy. I can just divide those. So let's just keep this as the 5 and the 3 don't go into each other. So I might just draw a line. So just keep that as like 5 over 3. But then we can go 300 divided by 50. So this is root 6. And then it's like canceled in the bottom. So there you go. That is rationalized. I don't really need to do any more there. You might write a little different. This would just showing you different forms here. This could be written like 5 over 3 times root 6. Maybe you'd see it written that way. Or maybe it was 5 root 6 all over 3, written a little nicer. So I remind you that like those are all the same thing, right? They can just be written a little bit different in math. Okay. All right, E. Okay, so the mistake here that might be made is students might say, aha, cancel those 6's. But if you remember with algebra that you can't do that in algebra either when you have like a binomial like this, some term times another term. What this really means is this is really root 6 plus root 2, and then it's over root 6, and this is also over root 6, right? Like when it's all over root 6, that's what it really means is this. So I can't just cancel those because it's like I'm pretending that it wasn't underneath the root 2, right? So we can't just cancel there. Okay, so different method. What we're going to do is rationalize this. So we are going to multiply by root 6 over root 6. Now, remember to put brackets there. And what we're going to do here, like the bottom will be easy enough for the denominator. I got root 6 times root 6. That's just going to be 6. So nice. But the numerator, I've got a binomial times a monomial here. I'm going to just multiply that in. So the first one, root 6 times root 6 was just 6 plus, and then root 2 times root 6 is going to be root 12. Now that's looking pretty good, but I do notice that we could rewrite the 12 as a 4 and a 3. So let's do that. So we got 6 plus 4 times 3 over 6. Now the 4 gets to come out as a 2. Now we've got 6 plus 2 root 3 all over 6. Now, for the most part, this would be an acceptable answer, but we actually can get a little simpler than this. And this will be a little bit more of an advanced step, but I know you guys can do it because you've factored before. So like I was just saying, like we're going to factor out what we can in the numerator here now. So if you remember it, so you've got 6 and you got a 2. What we can do is we can factor out a 2 because 2 is common to both of those. So you got 2 bracket 6 divided by the 2 we took out is 3. And that 2 is gone. And that's all over 6. Now you might be saying, why did I do that? Well, when we factored out that 2, now I can cancel it with the 6 on the bottom. This is like a fraction that I can just simplify. So the 2 cancels with the 6. This is like 1 over 3. So what we have left here is 3 plus root 3 all over 3. Right? Because it's like 1 over 3, but you'd probably just write it like this. For this one, I am going to rewrite this 80 right off the bat. Just rewrite this as 16 times 5, so we can simplify it. And then I'm just going to write everything again. 2 root 3 over 3 root 5. All right, so that gets to come out as a 4. So what I have left here is 4 root 5 plus 2 root 3 all over 3 root 5. Okay, perfect. So now we're going to rationalize this. And the way we're going to do that is we're just going to multiply by root 5 over root 5. That's all we need to multiply that by, not 3 root 5. We don't need that. I'm going to put brackets around this to remind myself. Okay. Yeah, let's do the top first. So I need to multiply by both of those. So what we have left here is just 4 times, and then what I have here now is root 5 times root 5. That is just straight up 5. So like 4 times 5. Plus, and then we have 2, and then root 3 times root 5 is root 15. All over 3. And then root 5 times root 5 is just straight up 5. So let's simplify that a little bit. What we have left there is 20, right? 4 times 5 plus 2 root 15 all over 15. And I could factor out a 2 like I did in the top one, right? But that's actually not going to help me because I'll factor out a 2 and then the 15 is not even anyway, so I can't even simplify it. So this is a perfectly fine way to leave your answer there. All right, simplify the following radical expression by rationalizing the denominator first, then simplify.